Hello, my name's Tim Pine from Footprint. We are here today to talk about zero carbon steel. It was quite interesting a few months ago to see these pictures suddenly appear of this possible new coal mine that was going to be given permission in the west of Cumbria. And we were amazed actually that anybody was even considering doing another coal mine. They'd obviously done some quite nice little pictures of it to make it look like a cuddly toy. But the reality of it was we were all quite surprised. The truth of the matter is that it was actually producing coke for steel production. And the reason that they're doing this is that steel, aluminium and glass all need an awful lot of energy, which is very difficult to provide from renewable sources. Obviously, you've got options like green hydrogen and all the rest of it coming along, but it all seems to be a long way in the future. We're very aware of the fact that the next generation is going to start asking about the embodied carbon of the buildings that they're starting to occupy. And so developers have got to get really to understand about where they should be getting their materials from. Today, I've got Walter Swann from ArcelorMittal. He's sort of their UK head of research. And I've got Diego Phillips, who's one of the
Net Zero
leaders at WSP. So, Walter, tell us what's in the pipeline.
There's quite a lot in the pipeline for the steel industry. Generally, we're committed to net zero by 2050. And we've set interim targets, or many companies have set interim targets of a 30% reduction by 2030. And for a carbon-intensive industry, that is quite a significant challenge. ArcelorMittal, we're taking kind of two approaches to the problem. The first one is a suite of technologies which we've called smart carbon. And that's effectively working with the blast furnace asset, the most common way to make iron and steel. And we're doing two things with the blast furnace. First of all, we're displacing fossil carbon in the form of pulverized coal. And instead of injecting pulverized coal, we're going to inject waste materials. It could be waste wood, which would therefore be a circular form of carbon, or it could also be waste plastics as well.
So that's using the existing furnaces?
It's using the existing assets, yeah. Yeah, so it's also a process which we can adapt relatively quickly. So we can do this in a 5-year time frame. And the other part of the process is to actually capture the top gases and basically filter out the useful ones, principally carbon monoxide, turn that into bioethanol, which can then be used either as a fuel or as a building block to make plastics. So again, you've got that circular thing happening where you're possibly putting waste plastics into the blast furnace and then getting material or product off the top, which you can then turn back into plastics. And the other aspect is to capture the carbon dioxide and then store that underground in a safe place. And using that mix of technologies, we actually think it's possible to become carbon negative.
Is the product the same? It's interesting because you came down on the train this morning from Newcastle, didn't you?
Yeah.
And it was cracked. And the steel was cracked and everyone was going, well, where did that steel come from then? Because steel doesn't normally crack. And you can imagine the guys that work for British Rail saying, well, they obviously weren't using British steel, were they? Is it all the same stuff?
The product essentially doesn't change. So you will not see a physical change in the products that you use in your buildings, the sections, the beams, the columns. They will look exactly the same. It's just the manufacturing process which is being adapted. We won't become more efficient. What we'll become is we'll pollute less, and ultimately we'll get to a point whereby we don't pollute at all.
Do you find that people are really interested in, first thing they say is, how much is this stuff going to cost?
Absolutely, and I think the important thing is that the element itself, it's the same, but trying to understand what goes before that, what happens for that element become steel and how we can decarbonize that process is really important. And of course, how do we drive that change and at what cost? Our clients are focusing on decarbonizing their own assets. They have the sustainability agenda really a top priority. And we need to help them to understand what are the implications in terms of cost, in terms of program, and in terms of quality as well. Because like you said, in the future, and not in the future, right now, people are already asking about the embodied carbon of your buildings. And the cost and the revenue of that asset will decrease if we don't focus on reducing the amount of embodied carbon that we put into our buildings.
So is there a kind of certification then, where you can say to the developer, this is your certification that you can now show your future tenants or the people who are going to buy your building to guarantee that we've used this low carbon steel?
I think the high level thing, a lot of people will be familiar with the Certified Timber Schemes, FSC, which basically kind of create a chain of custody of responsible sourcing of a building product, i.e. timber. In the steel industry, we have something similar, which is starting to pick up momentum, and it's called responsible steel. So that's an environmental, social governance standard. But the key thing which makes it different, I think, to anything else out there is the fact that it's tied into the Paris Agreement. So if you source your steel from a responsible steel certified company, you're automatically getting product which is aligned with your aspirations and with the aspirations of the Paris Agreement.
I would have thought that was critical, isn't it?
It's absolutely, because it is like a virtuous circle. But someone has to start it. We have to decarbonize the production of primary steel, but to do that, we need to show the industry that there is demand for low carbon steel. So options to generate demand for it are important to drive this virtuous circle. And certification is, for example, one of them.
So when a client comes to you and says, okay, I'd like to design this building for me, is there any point in the early design discussions when you start saying what kind of steel are you going to be using?
It should be one of the first questions that you ask.
Right at the very beginning.
Right at the very beginning. One of those first meetings might be the one that determines the fate of your building. So the carbon content of the material of choice has to be discussed from the earliest stages.
And in your website, do you make that really easy to understand right at the beginning? Because I know developers, and I think that they'll look at this kind of stuff, but as soon as it becomes really difficult to understand and all the rest of it, they'll be moving on to the next thing. And I think this whole certification thing is really important. So, they go, oh, actually, do you know what? That makes sense. I get that. Let's do that,
I think the important thing about the certification scheme or responsible steel is that it tackles primary steel making, i.e. blast furnace steel making. So, I haven't mentioned it yet, but steel is made by another process, which is from scrap in the electric arc furnace. And I know you probably don't want to talk about figures, but if I just give you two figures to think about, blast furnace steel typically has an embodied carbon of 2,500 kilograms of CO2 per tonne. Steel made in the electric arc furnace from scrap has an embodied carbon of 500 kilograms of CO2 per tonne.
But there isn't enough scrap, is there?
But there's not enough scrap. And that's the problem. So everybody sees the difference in those numbers and says, yes, we'll go for that one because that makes sense and it can have a huge impact on our embodied carbon. But the fact of the matter is that at any one time, there's only about 30% of scrap relative to demand in circulation. So that's the issue that we have as an industry. That's why we need to tackle primary steel making.
It's interesting that they don't bring ships over here to break them up. You could probably use them quite well, couldn't you, really? Instead of sticking them on the beach somewhere in India.
As designers, and we specify steel, we could try to specify much more steel from scrap. But like we said, it's just not there's not the sustainable answer. We have to focus on decarbonizing the primary production of steel. So initiatives like responsible steel, certifications of responsible steel, and initiatives like Steel Zero are trying to achieve that, to drive that demand up.
And it's interesting as well because just to hear you two speak, and myself as well, we've talked in terms of steel. And as an industry, when we talk in terms of steel, we don't just think in terms of the built environment. We think in terms of the automotive industry. We think in terms of white goods. We think in terms of tin cans. Wind turbines. So steel's a really broad material. When you start to talk about using different products, using different processes, it's important to start to talk about those products specifically. So if you talk about reinforcement or rebar, as a specifier, you have a choice of process route. You can get reinforcement that's made using primary steel making from the blast furnace. You can get reinforcement that's made from the scrap method using the electric arc furnace. With section, you have a choice. You can get blast furnace product, you can get electric arc furnace product. When it comes to things like cladding, when it comes to things like decking, at this point in time, there is only one source, and that tends to be a blast furnace source.
And that's the one that uses all the carbon.
And that's the one that uses all the carbon. So if specifiers are going to try and single out a process such as electric arc furnace, they've got to do that with some knowledge of the supply chain and the way that products are made.
Why is it that you can only use the stuff that comes from ore, as it were, for things like cladding? Why? I thought it's the same product. Is it not the same product?
You can make anything from primary steel, so iron ore, from the blast furnace. You can make anything from the electric arc furnace. But there's a certain natural transition. So if you did nothing in the steel industry, if we didn't have this carbon agenda, what would naturally happen is that scrap, the volumes of scrap would gradually build, and the industry just naturally would progress towards electric arc furnace manufacture. That would happen. All we're trying to do as an industry now is really trying to facilitate that happening more quickly.
I didn't know that you could use electric arc. You could use electricity to get from scrap to steel that you actually could use, but you can't use electricity to get from iron ore to stuff that you could use, because the stuff that you need right at the beginning needs too much energy, and therefore you have to use coke. I didn't understand that.
Yeah, the coke that you use in a blast furnace, it's not so much about energy, it's about using that in a chemical reaction. So that's the subtle difference. Whereas in an electric arc furnace, you're taking a physical piece of steel and you're really just applying enough heat so that it melts down to a liquid. Yeah.
So there are ways of making low carbon steel at the moment, but they need to use electricity and therefore they need to come from scrap. Is that right?
Yeah, that's right. So, one of the low carbon ways is with the electric arc furnace, where we just melt down scrap. And as I said before, that means that the embodied carbon factor is around about the 500 kilograms of CO2 per tonne of steel mark. We can take that further by tapping into a decarbonised electricity grid. And there are offerings on the marketplace now where you can get that 500 down to, round about the 300 mark. So that's possible now, today. But there's another kind of process which I wanted to talk about, if I may, and that's hydrogen steel making.
Yeah, you can't get the hydrogen at the moment, though, can you?
Well, you can't. Well, you can. You can get the hydrogen, but you can't get the hydrogen that we want, which is green hydrogen. Yeah. So, as a company, we're investing in pilot plants which will produce steel using hydrogen reduction. And for the chemists who might be listening in, that basically means that what you emit to atmosphere is water. So you eliminate carbon dioxide altogether. And as a company, we're starting to transition to that. But we don't think that the rest of the industry, the power industry, the hydrogen industry, will be ready to support us probably for another 10 to 15 years. But we do have a role to get our processes aligned and hydrogen ready.
And that's why it's so important to know what your supply chain does. Because as designers, we're at one end of the supply chain. And then we need to know what our steel fabricators are doing, and then the steel suppliers as well. So where are they getting this steel from? So understanding the entire supply chain is incredibly important, so that you know where your product is coming from. But something else is that, of course, if we want to go even lower carbon steel, what about the steel that we already have in buildings? Buildings that have steel columns and steel beams which are in perfect state. And how do we reuse them to actually have zero carbon steel? So reusing existing buildings is actually what we are trying to address at the beginning of every project. You know, we said about those early conversations. The first question will be, can I use what I already have? Or can I take it from somewhere else? How can I meet those stockholders, steel stockholders, find what sections they have and bring them to my project and actually have a truly zero carbon.
Oh, I see. So you're talking about dismantling the building, taking the steel away, putting it in a place, bringing it back out again.
Yes, or taking that from an existing building that is going to be demolished. Mm-hmm. So demolishing it carefully so that we can reuse the sections somewhere else. And we can work together with architects and steel fabricators. So even if the steel section is a little bit bigger than your design, it still doesn't matter. Exactly.
Yeah.
And it's interesting that, isn't it? Because one of the inherent benefits of steel construction is that it is the ultimate Meccano kit, isn't it? Exactly. You do take things and you bolt them together, and obviously if you can bolt things together, then that means it lends itself to creating a demountable structure.
Exactly. And they say that steel is one of the only truly circular materials. But currently, a vast majority of the steel that we take down from buildings is transported out to China and melted back and produced back into steel sections.
They take it to China to do that, do they?
Why not do that here? But also, why not reuse those perfectly fine sections?
Walter and Diego, it's been a fascinating conversation today. I hope your train doesn't crack on the way home, Walter. It was a Hitachi, wasn't it?
It was. It got me here, so hopefully it'll get me back.
You don't know who made the steel?
No, I'm afraid not.
Whether it was made out of scrap or not. Anyway, thank you very much for coming.
Thank you.
Thank you, Tim.
See you both in Brighton.